The fourth demerit of Mendeleev's periodic table is regarding the position of hydrogen. Hydrogen shows similarity with halogens which are placed in group 7 as well as alkali metals which are present in group first. Here from the table, let us see what are the similarities. Here in first table, hydrogen forms compound with chlorine, oxygen and sulfur in the same manner as sodium forms the compounds with these corresponding elements, and therefore we can see the similarity in hydrogen and alkali metals, as sodium is an alkali metal. Now in next table, hydrogen and chlorine forms compound with metals like sodium and non-metals like carbon in similar manner, and therefore similarity is there in hydrogen and halogen, and due to this it is very difficult to place hydrogen in Mendeleev's periodic table. Now to overcome these demerits, some scientists came forward and they performed some experiments. For example, here in 1913, the English scientist Henry Mosley demonstrated with the help of the experiment done using X-ray tube. Here Henry Mosley is shown in picture, and he has a tube which is nothing but X-ray tube, and by using this X-ray tube he demonstrated an experiment and he put forward that the atomic number which is denoted by Z of an element corresponds to positive charge, and that positive charge is nothing but due to protons present in nucleus of the atom of that element, and therefore the number of protons is nothing but atomic number. Therefore this revealed that atomic number is more fundamental property of an element than its atomic mass, and accordingly the statement of the modern periodic law was stated as follows: periodic properties or properties of elements are a periodic function of their atomic numbers. That means before, आधीच्या शास्त्रज्ञांनी म्हणजेच डोबेरायनर, न्यूलँड्स आणि मेंडेलीव यांनी ॲटॉमिक मास जो आहे ती फंडामेंटल प्रॉपर्टी ॲझ्युम केली होती, पण ह्या हेनरी मोजले ह्यांनी जो काही एक्सपेरिमेंट केलेला आहे, जो डेमॉन्स्ट्रेट केलेला आहे, त्याच्यानुसार ॲटॉमिक नंबर इज मोर फंडामेंटल प्रॉपर्टी हे पुढे आलं, आणि त्याच्यावरूनच अ लॉ, पिरियॉडिक लॉ विच इज ऑल्सो नोन ॲज मॉडर्न पिरियॉडिक लॉ हा समोर आला, अँड प्रॉपर्टीज ऑफ एलिमेंट्स आर अ पिरियॉडिक फंक्शन ऑफ देअर ॲटॉमिक नंबर हा लॉ स्टेट केला गेला किंवा पुढे ठेवला गेला. अँड by using this law, the elements were arranged. इथे आपल्याला दिसतंय की पिरियॉडिक टेबल एका विशिष्ट मॅनर मध्ये प्लेस केलेला आहे, आणि इथे दिसतंय की प्रत्येक एलिमेंटचा यूज काय आहे. अँड यू कॅन ऑब्झर्व दिस पिरियॉडिक टेबल व्हेरी केअरफुली by pausing this video. Now let us see what is the structure of this modern periodic table. The modern periodic table is also called the long form of periodic table. In the modern periodic table, the elements are arranged in accordance with their atomic number. As a result, most of the drawbacks of Mendeleev's periodic table appear to be removed. कारण atomic number च्या accordingly हे एलिमेंट्स प्लेस केल्यामुळे जे काही ड्रॉबॅक्स मेंडेलीव्स पिरियॉडिक टेबल मध्ये होते ते रिमूव्ह झाले. द रिलेशन बिटवीन ॲटॉमिक नंबर ऑफ एन एलिमेंट अँड इट्स इलेक्ट्रॉनिक कॉन्फिगरेशन इज क्लिअरली सीन इन द मॉडर्न पिरियॉडिक टेबल, as atomic number is used to arrange the element, and there is a relation between atomic number and electronic configuration, and therefore it is clearly seen in the modern periodic table. Now let us see what is the structure of this modern periodic table. जर आपण नीट लक्षात घेतलं हे मॉडर्न पिरियडिक टेबल, तर प्रत्येक एलिमेंटला एक छोटी छोटी खोली दिलेली आहे, बॉक्स दिलेला आहे. असं आपण म्हणू शकतो की हायड्रोजन पासून ते इथे 118th एलिमेंट पर्यंत सगळ्यांना एक एक बॉक्स दिलेला आहे. ईच एलिमेंट्स हॅव सिंगल बॉक्स and this single box is nothing but a part of vertical and horizontal lines, part of a table. एक टेबल बनवलेला आहे, याच्यामध्ये horizontal lines आहेत आणि vertical column आहेत. Let us see what is the structure. There are total 7 horizontal lines. जर आपण इथे काउंट केलं, हायड्रोजन टू हेलियम, this is first line, then lithium to neon, second, sodium to argon, third, potassium to krypton, and so on. Here this is fifth line, sixth and seventh. That means there are 7 horizontal rows which are named as periods, and 18 vertical columns from 1, 2, 3 onwards up to 18. There are total 18 vertical columns, and these columns are known as groups. That means modern periodic table consists of 7 horizontal rows called periods and 18 vertical columns called groups. Then here you will find there are total 4 blocks: S block, then P block here, then D block in the middle of the table, and at the bottom F block. These 4 blocks S, P, D, F are made according to the electronic configuration of that element. आपण आधीच पाहिलेलं आहे की इलेक्ट्रॉनिक कॉन्फिगरेशन जे काय आहे, जे पिरियडिक टेबल मध्ये, मॉडर्न पिरियडिक टेबल मध्ये क्लिअरली दिसते. आणि इथे आपल्याला दिसतं की अकॉर्डिंग टू द इलेक्ट्रॉनिक कॉन्फिगरेशन दे आर अरेंज्ड इन 4 ब्लॉक्स. आता हे 4 ब्लॉक्स काय आहेत, तर एस ब्लॉक मध्ये ग्रुप फर्स्ट अँड सेकंड हे एलिमेंट्स आहेत. पी ब्लॉक मध्ये ग्रुप 13 to 18 यामध्ये येणारे एलिमेंट्स आहेत. डी ब्लॉक मध्ये ग्रुप 3 to 13 यामधले एलिमेंट्स आहेत. Now let us see what is the structure of modern periodic table. इथे आपल्याला दिसेल की प्रत्येक एलिमेंटला एक वेगळं बॉक्स दिलेला आहे, and that box is nothing but a part of a table, and this table consists of horizontal rows and vertical columns. These horizontal rows are known as periods and vertical columns are known as groups. And here you will find that there are total 7 horizontal rows. Here hydrogen to helium, lithium to neon, and so on. We can count it. We will find that total 7 periods are there and total 18 vertical columns which are known as groups from 1 to 18. They are numbered as 1, 2 to 18, and in such a manner modern periodic table consists of 7 periods and 18 groups. Then there are total 4 blocks according to their electronic configuration. Here you will see in group first and second the electronic configuration is almost similar, therefore they are placed in S block. Then P block consists of the group 13 to 18. Then D block consists of group 3 to 12, and all these elements are under group or are under block D block elements. And the bottom F block element is present at the bottom of the periodic table. It consists of total 28 elements, 14 elements in each row, and they are known as lanthanides and actinides. Then here one more separation is there. here you will find one zigzag line is there, and along this zigzag line all the metalloids, that metalloids means the elements which shows properties of metals as well as non-metals. That means they shows some properties similar to metals and some properties similar to non-metals, and they are known as metalloids like boron, silicon, germanium, and these are the arsenic, and these are placed along a zigzag line in a periodic table, and this zigzag line separates metals from non-metals. That means you will clearly see all the metals are placed on the left side of the periodic table and non-metals are placed at the right side of the periodic table, and metalloids are placed along the zigzag line. इथे तुम्हाला स्ट्रक्चर नीट लक्षात आलं आहे की तिथे 7 पिरियड्स आहेत, 18 ग्रुप्स आहेत, 4 ब्लॉक्स आहेत आणि 4 ब्लॉक्स कशा प्रकारचे आहेत हे पण आपण पाहिलेलं आहे. त्यानंतर मेटल्स लेफ्ट साइडला आहेत, नॉन मेटल्स राईट साइडला आणि मेटलॉइड्स अलॉंग द झिगझॅग लाईन बिटवीन मेटल्स अँड नॉन मेटल्स. आपण आताच पाहिलं की इलेक्ट्रॉनिक कॉन्फिगरेशन आणि मॉडर्न पिरियोडिक टेबल ह्यांचा काय संबंध आहे, किती जवळचा संबंध आहे. नाउ वी विल सी द ग्रुप्स अँड इलेक्ट्रॉनिक कॉन्फिगरेशन. Group means vertical columns. Now if you observe some elements shown in figure, that hydrogen, helium, sodium, potassium, you will see all the elements have only one valence electron in their outermost orbit, and that means they have same valency. That means down the group, if we write their electronic configuration, we will find same number of electrons present in their outermost orbit. Similarly here, beryllium to calcium, 2 electrons each present in outermost orbit, and therefore the electronic configuration shows some similarity in groups. Now in periods what happen, here you will see in second period, here from lithium to neon, here you will clearly notice that number of shell remains same. That means here 2 shells are there, K and L, here also 2 shells, and number of shells are remain same, and only one electron gets added in outermost shell. Here in outermost shell 1 electron is there, in beryllium 2 electrons are there, in boron 3, and so on to neon total 8 electrons are there. That means in periods electronic configuration also similar. That means they have same number of shells, but just goes on adding, there goes on adding 1 electron in outermost shell. And here in groups we have seen that number of shells goes on increasing down the group. Here only 1 shell is there, then here 2 shells are there, here 3 shells, and here 4 shells. In groups, as we go down the group, number of shells goes on increasing, but in periods the number of shells remain same, but number of electrons goes on increasing in outermost shell. Now to understand the electron capacity of electron shell, we have to use one formula. That formula we have learned in previous standards, 2n square, where n is number of shell, that means shell number. Here for K shell number is 1, for L shell number is 2, for M shell number is 3, and for N shell number is 4. And if we put the value of n in this formula, we will get electron capacity. Here we will find that electron capacity of first shell is 2, that of second shell is 8, and that of third shell is 18, and fourth shell has capacity 32. as per electron holding capacity of shell, 2 elements are present in the first period and 8 elements in the second period. And the third period also contains only 8 electrons due to law of electron octet. The outermost orbit can, the law of octet means what? The outermost orbit can hold only 8 electrons. It can occupy with 8 electrons only. More than 8 electrons cannot be occupied in outermost orbit. The chemical reactivity of an element is determined by the number of valence electron in it and the shell number of the valence shell. That means the chemical is how reactive, how much reactive is that chemical is depend on, or its reactivity is determined by the number of valence electron and shell number. Now some periodic trends are there, as we have learned that atomic number is a periodic property or periodic function of properties of that element. That means as atomic number increases, their property also changes, and there is a periodic manner in their, or pattern in their property. Now let us see what periodic trends are there in modern periodic table. Now first periodic trend is valency. Now as we move across the row, that means across the period, the valence electron gets added in outermost orbit, and number of electron gets added in outermost orbit. As number of electrons goes on adding, the valency changes, and valency is nothing but the capacity of element to take part in, and valency is nothing but capacity to take part in chemical reaction, and which is depend on the number of electrons present in outermost orbit. Here if he goes on moving from left to right of the periodic table, number of electrons goes on adding in outermost orbit. And let us take an example. If there is 1 electron in outermost orbit, it will easily be donated by this element, and therefore its valency will be 1. If number of electron here for beryllium, number of electron in outermost orbit is 2, then it can donate 2 electrons. Here 3 electrons are there, that means it can donate 3 electrons. Now here 4 electrons in carbon, so there are some periodic trends in modern periodic table. Let us see which are they. They have valency, atomic size, and metallic and non-metallic character. That means these all trends are depend on electronic configuration of elements. Let us see one by one. Valency. Valency depends on number of electrons present in outermost orbit. As number of electron goes on increasing, its valency will also change, or as number of electrons in outermost orbit changes, its valency changes. Let us see in second row, that means second period, the valency will goes on increasing up to fourth group. Why? Because in fourth group outermost orbit contains 4 electrons, and afterwards valency goes on decreasing, because as there are 5 fifth group. Now we have seen that in periodic table, that is modern periodic table, elements are arranged in increasing order of its atomic number, and therefore there is some regularity in properties of the elements, and these regularities are called as periodic trends. There are number of regularities or number of periodic trends are there, but we will see or try to understand some of these 3 periodic trends like valency, atomic size, and metallic and non-metallic character. Now, let us see first valency. Valency is nothing but capacity to react or take part in chemical reaction, and it depends on valence electron. Now, valence electron means electrons present in outermost orbit. Now, in this table here, valence electrons present in outermost orbit are given. Here you will see the electrons, that is valence electrons, goes on increasing from left to right. As valence electron goes on increasing, valency also changes. That means if number of valence electron is 1 or 2 or 3, the valency will be same as number of valence electron. Now here in fourth group, the valency is 4, as the valence electron or number of valence electron is 4, and it can donate or receive, or it can form a covalent bond by using these electrons, and therefore its valency is 4. And now if valence electrons are increased from 5th, 6th, 7th and 8th group from 5 to 8, here for valence electron, number of valence electron 5 to 7, it will be more easier to receive electrons to attain nearest noble electronic configuration or noble stable electronic configuration. Now let us take an example of this. If for this group the valence electron are 5, and therefore it is easier to receive 3 electron to attain its stable electronic configuration. That means its octet state. To complete its octet, it wants only, or it requires only 3 electrons. Here it requires 2 electrons, and here it requires 1 electron. Therefore this group will show valency 3, this group will show valency 2. The valency of this group will be, that means halogen group will be 1. That means from left to right, valency goes on increasing up to 4, and then again it goes on decreasing up to 0. Now here they have inert gases, they have 0 valence electrons in their outermost orbit, because they have 8 electrons in their outermost orbit, and they already attain stable electronic configuration, and therefore they will not take part in chemical reaction, and therefore their valency is 0. Now down the group, what happens? The number of valence electron present in outermost orbit remains same, and therefore in groups valency remains same. Now second trend is atomic size. Atomic size is nothing but, now next trend is atomic size. Atomic size is nothing but distance from center of the nucleus to the outermost electron. That means valence electron or electron present in outermost orbit. That means distance from here, this outermost electron, to the center of the atom, of center of the nucleus of that atom, will be its radius, and radius is nothing but atomic size. Now here let us consider from period second, from group 1 to group 18. Here you will see that the size goes on decreasing from left to right. Why this happens? As we moves on left to right in period, the number of electrons goes on adding in outermost orbit. That means same shell, the number of electrons goes on adding. As number of electrons increases, the negative charge increases, and at the same time positive charge at the nucleus also increases, because number of proton and number of electron are same, and as charge increases there is attraction and there is a pull, and therefore electrons gets attracted or pulled towards the nucleus, and therefore size goes on decreasing from left to right in periods. Now what happens in groups? Now we have seen that in groups number of shells goes on increasing. That means in first period shell is 1, in second period shell is 2, 2 shells are there, and so on. Shells goes on increasing. As shells goes on increasing, the distance from nucleus to the electron which is present in outermost orbit will also increases, and therefore here we will find that as we move down the group, atomic size also increases. Now next trend is metallic and non-metallic character. First we have to understand what is metallic character. Metallic character means capacity to lose electron, and we have seen as valency or as valence electrons present in these groups, that means group present on left side of the periodic table, their valence number of valence electrons are 1, 2 or 3. Therefore they can easily lose the electron, and the elements which are present on the right side of the periodic table, they have valence electron more than 4, and therefore they tend to receive the electrons, and capacity to lose the electron is nothing but electropositivity. That means electropositivity is shown by metals, and therefore electropositivity goes on decreasing. That means metallic character goes on decreasing from left to right, and non-metallic character goes on increasing. That means electronegativity goes on increasing from left to right. Now let us consider down the group. Down the group, as we move down the group, the shell goes on increasing. Number of shells goes on increasing. As number of shells increases, distance increases, and therefore attraction between outermost electron and nucleus decreases, and as attractive forces decreases, they tends to lose the electron. Tendency to lose electron will also increase. That means as we move down the group, the electrons can easily donated, and therefore as we move down the group, metallic character also goes on increasing. Here we can see from left to right, atomic radius increases, then increasing electronegativity and non-metallic character, and decreasing electropositivity and metallic character. That means from left to right, metallic character goes on decreasing, and down the group, increase in atomic radius and decreasing electropositivity and non-metallic character. Non-metallic character goes on decreasing, and there is decrease in electronegativity, and therefore there is increase in electropositivity and metallic character. Now there is one speciality in periodic table, that is halogen family. Halogen family means the elements which are present in group 17. The group 17 contains the members of halogen family, and all of them have the general formula X2. X2 means most of them are gaseous. they are gaseous, therefore their general formula is written as X2. A gradation is observed in their physical state down the group, and thus fluorine, chlorine, then bromine and iodine have some gradation in their physical properties. What are they? That fluorine and chlorine are present in gaseous state. Then bromine is found in liquid state, and iodine is found in crystalline, that means solid state. And this gradation is known as gradation in halogen family. And here you will see the halogen family is placed in group 17. So dear students, in this lecture we have learned elements and their classification. What is the need of classification? And to fulfill the need, Dobereiner, Newlands and Mendeleev tried their best to classify the elements. The Mendeleev classify, though the Mendeleev classify the elements which were known at that time, there are some merits and demerits which were overcome by modern periodic table. And we learn the structure of that periodic table, electronic configuration and periodic table. What is the relation between electronic configuration and position of element in periodic table, then trends in periodic table, and lastly the gradation in halogen family. I hope you must have understood all the topics which we have covered today. मला वाटतं तुम्हाला आपण जे काही शिकलो ते नक्कीच समजलं असेल. And hence, with the best wishes, I will take a leave from this lecture. Thank you.